What's up, math scholars and math haters? This is Mr. W. Today we are going to start a 4-video series on what I believe is one of the most important and useful ideas in statistics and in mathematics in general. You can probably guess from the title, it is the normal distribution. If you've seen any kind of bell curve that looks like this, that is what we mean by a normal distribution. And if you've seen my previous binomial probability videos, this essentially comes from taking binomial probability and doing it not with maybe 4 or 5 trials, but doing it with about 1 million. So the basic shape does come from something that we have covered before in terms of the various probabilities. But today I want to start by just going over exactly how to label this thing. Because if you don't know how to label it, you don't know how to use it or understand it. First thing I want to point out with this normal distribution is that we have 3 measurements of center that are actually all in the same place with this particular distribution. So we have the median, and the median, of course, is the exact middle of the data. We have the mean. The mean is like the balance point, and if our data is symmetrical, as this normal distribution is, then our mean is going to be right in the middle. And our mode is going to be the highest point of any hump, or in general a mode is a hump, but the actual mode we could think of as the highest point of that hump, and that is right here in the exact middle. So the mean, median, and mode are all going to be in the exact middle of this data distribution. Now, here's where we get to where we actually use it. Because if you look and see here, I have something here about IQ scores. Now, the deal with IQ scores is that as people kept doing IQ tests, they realized that IQ basically fit into this kind of distribution, this kind of normal distribution. And they realized, or some people realized, some people decided that they should tweak the test a little bit so this would be true. They decided that the mean of IQ across the board for everybody was 100. And the standard deviation of these IQ scores was about 15. So the first thing we're going to do is we are going to label this normal distribution with appropriate numbers at each of these tally marks. And each of these are going to require 2 numbers. First, the top set of numbers will actually be the same on every normal distribution that you see. So this blue line that I've marked out as the median, mean, and mode is going to be our mean, but in terms of standard deviations, we are going to call that 0. Now from here, I want you to think of this line, measuring in standard deviations, thinking about standard deviations as a number line. So as we go right, we would be going 1 standard deviation, 2 standard deviations, 3 standard deviations to the right, and as we go left, we would have to get into the negatives. -1, -2, -3 standard deviations. Again, at this point, we're just thinking of this like a number line. The next set of numbers that you would write is where it gets a little bit trickier, and this is where we have to actually build off of our mean and standard deviation. So what I'm going to do is I'm going to start by saying that my mean, this Greek letter mu here, not the Pokemon, the Greek letter, I would call this 100. That mean of 100 is at 0 standard deviations in either direction. As I go right, since I added 1 standard deviation as I'm going right, I'm going to add its equivalent in IQ scores. So 1 standard deviation would be 115. 2 standard deviations would be 130. And then 3 standard deviations would be 145. On the left side, it's the same idea. I'm subtracting 15, subtracting 1 standard deviation as I go to the left. So 100 minus 15 is 85. 85 minus 15 is 70. And then 70 minus 15 is 55. Now, generally, you would not be asked to fill in more than 3 standard deviations in either direction for one of these if you were asked to do this. But if you had to go to the -4s or the +4s, you would just keep adding or subtracting 15, your standard deviation that you're given, as you go to the right or to the left. So let's do this again. Let's think about delivering pizzas. I think about delivering pizzas a fair bit, since I actually used to do that for a job. And if we're working for a pizza place, let's say that the mean of their delivery times was 25 minutes, and that their standard deviation was 8 minutes. As you can see, I already have my standard deviation number line written down here, so I'm just going to go ahead and fill in the rest of it. I'm going to start by filling in my mean right down here. That is 25. And as I go right, I'm going to keep adding 8. So 25 plus 8 is 33. 33 plus 8 is 41. 41 plus 8 is 49. And I would keep adding 8 if I had to keep going right to 4 or more standard deviations. As I go left into the negative side of the standard deviations, I need to subtract 8 from my mean every time I want to go deeper into the negative. So 25 minus 8 is 17. 17 minus 8 is 9. And 9 minus 8 is 1. Now this is actually where we get into one of the weaknesses of just thinking of one of these normal distributions in terms of mean and standard deviation. Hardly any delivery I ever made only took 1 minute. And when we get into actual percentages of these sections here, I would doubt that even the appropriate percentage of deliveries would have taken 1 minute or less. So there's a very, very slight weakness here, but it's still one of the most useful and applicable parts of statistics and of math in general. So that is the very basics of how to fill in the information for one of these normal distributions.